So the pop quiz related to unit 1 and 2, the pop quiz 1. First question related to unit 1, a projectile question. A stone is projected horizontally. So this is a horizontal velocity is there. What about the vertical velocity? Because it is moving horizontally, so the vertical velocity will be 0. The height the stone move, that is 12 meter. Calculate the horizontal distance. So we want to calculate this range. So if you need the range, we have the formula that speed is distance divided by time. So distance, if we need, it will be speed multiplied by time will be equal to the distance. But first we have to calculate the time. The time it takes. So first we have to calculate the time, how much time it will take to fall. So we'll use the formula, the equation of the motion, because we have the vertical displacement is there. So first we'll work out the time by using we have the displacement S is there. Initial is 0 and we need time. So we can use equation of motion like S is equals to ut plus half at square. Where vertical initial, whenever you use equation of motion, you always use the vertical components in that. So this vertical displacement is 12, initial velocity is 0, half acceleration will be due to gravity 9.8 and then t square. So this factor will be 0, so 12 is equals to half 9.8 t square. If we need t, it will be 12 multiplied by 2 divided by 9.8 in a root. So that will give us how much time it will take to fall, which is about 1.56 seconds. So after getting this, we need the range, the distance. So we have the horizontal speed. For speed is distance over time in this equation, because in horizontal component there is no acceleration. So we use this formula. The speed is given. The horizontal speed is given, which is 3.8, and the time it took is 1.56. So when we multiply, the horizontal distance will be 5.94 meters. That will be the horizontal distance. So the vertical component, we use the equations of the motion. The horizontal component, speed is distance over time. And if we change the horizontal speed, for example, if we launch this at different horizontal speeds, the time, it will take the same time. The different ranges will be there, but the time will be same. Because if it is dropped from a same height, so it will take the same time to fall, as the vertical and horizontal motion are independent of each other. This question is related to the nature of the light. A particle of a light at a speed 9.89 exponent 5, the de Broglie's wavelength, deduce whether this particle has a mass equal to electron. So we have the formula lambda equals h over mv, or h over p, you can also say. The de Broglie's wavelength is given 7.37 into 10 to the power minus 10. H refers to the constant, the Planck's constant. And the value of the constant will be given in exam. You don't have to memorize the value for the Planck's constant. It will be there. So in a constant value, just you have to use that. So the Planck's constant is 6.63 into 10 to the power minus 34. So 6.63 into 10 to the power minus 34. M is the mass which you are finding, and the speed which is given, that is 9.89 into 10 to the power 5. So the M is our subject, so we'll find the M from this. And after finding the M, we'll compare. Say it is coming out 9.1 into 10 to the power minus 31 kg. So we'll compare, and that matches with the mass of electron. So this means this is electron. A question related to fluid. A student determined the viscosity of a liquid using the following method. The drag equals weight minus the upthrust. The density of a liquid is known. The student used a balance in the digital caliper to measure, to make measurements. Describe how student could use her measurement to calculate the value for the drag. So what is drag? Drag is weight minus upthrust. And what is weight? Weight is mass into gravity. And what about upthrust? Upthrust is density of the fluid, volume of object, and gravity. And usually this is used for a spherical object. So this will be mass into gravity. My density of the fluid will be there. What about the volume of object? Because a spherical object, so it is 4 by 3 pi r cube into g. So what we need the mass, like we'll measure the mass, and we can measure a diameter by using a caliper. And from that, we can work out the upthrust, and the weight, we mass into gravity, will get the weight and then use the equation. So you just, like, what you have to do, you have to just mention, we can calculate the weight. Weight will be mass in, we'll find the weight. Weight is mass multiplied by gravity, and mass we'll find by using the balance. And upthrust is equals to density into volume into gravity. As I mentioned already, that density of a liquid is known. So we know this value. Gravity is also constant. So what about the volume of object? Volume of object is 4 by 3 pi r cube. Volume of object is 4 by 3 pi r cube. So we have to work out the radius by using a caliper, digital caliper. This question is related to light. The ray of a light is shown before and after entering the prism. Determine the refractive index. So it's moving from air to glass. If we draw the normal, this will be the angle of the incidence. So it will be 90 minus 32. That will be the angle of incidence, which is 58. And this will be 90 minus 50, so that's equal to 40. And we use the formula N1 sine theta 1 equals N2 sine theta 2. N1 is a refractive index of the first medium, which is air in this case, so we write 1. And sine theta 1, that is 58. N2 is a refractive index of the medium 2. And sine theta 2, which is 40. So we need this. We can also write refractive index as mu. Like this is mu air to glass. Like the light is moving from air to glass. So we can write mu A and G. That's the same thing, no difference. So when we simplify, this will give us the refractive index to be 1.3. And refractive index does not have any unit, it's just a ratio. Discussion is related to the moment, center of a gravity and a point P is there, a force P is there. A stone has a weight of 415 Newton at a length and having a length of 0.9 meters. The length of a stone beyond the edge of a step, as you can see here, 0.5 meter as shown. The center of a gravity is at the center of the stone. Calculate the magnitude of a P. So P is acting here and weight is acting here. So this is a point of rotation. So one will cause a clockwise rotation, another one will cause a anti-clockwise rotation. So If this total distance, because like weight will act at the center. So if this is 0.90, so this distance from the center, this will be 0.45, and this distance will also be 0.45. So, but we always need a distance from the pivot or a point of rotation. So this one is the point of rotation. Around this point, this stone can rotate. So the distance here, because if this one is 0.54 and this total is 0.5, so how much is this? So this will be 0.05. And if this total is remaining, because if this is 0.45, like this total is 0.5, so how much is this distance? This will be 0.40, because the total is 0.9. So P into 0.40, which is causing an anti-clockwise rotation, equals to W into 0.05. And the W, the weight is given. So we just substitute the values. So instead of writing W, you can write 415. So 415. If we need P, it will be 415 into 0.05 divided by 0.40. So this will give us the value for the force which it will experience, which is about 51.9 Newton. So whenever you see a question related to moment, first thing, identify the point of rotation or a pivot, and then consider the clockwise and anti-clockwise moments are equal. The question is related to DC electricity. Wire W and Z are now connected in series. So two wires are there, they're connected in series. Whenever two wires are connected in series, they will have the same current, because current in series is same. So place a cross. So current, same value will be there for W and Z. Resistance. If you see, this wire is thinner wire because resistance is inversely proportional to area. If the wire is thin, the resistance will be large. So which one will have a large resistance? So it means W should have a large resistance. And when two components are connected in series, the one which is having a high resistance will have more voltage or potential. So the volt, and this has a low resistance, so it will have a less potential across it. So potential across the wire, W will be more. The drift speed of the charge carriers, we have the formula. We have the formula V is equals to IR. So V over R is equals to I. I is constant, like the current is constant in both. But for W, the resistance is high. So if the resistance is high and it has a more potential, so means the charges, because like number of the charges moving in 1 second, for W same as number of the charges moving in Z. But W is having a small area, so the speed, the resistance is high, so the charges should move much faster. So that's why the drift velocity should be larger in W as compared to that in Z. Otherwise, if Z was larger and because the resistance is low, so the charges will move, like more charges will come out every second. So as a result, the current will be different. We want the same current. So if you want the same, because current is equals to I is equals to NA VQ. So here I, we want the same, because for this one area is less, N is constant, the number of charge density, charge carrier per unit volume, Q is constant. So if here area is less, so means the charges should move faster, so that the product of I and V should be constant, or I remains same. For Z, what will happen if you use this I is equals to NAVQ? So what happened? Z is having a large area, so the charges should move slower and the product will remain constant. Like if area is increasing in series, the drift velocity should decrease. This question is related to the force and motion. The gymnast bounce on a trampoline. For each part of a motion is in contact. For the rest of each bounce, it's in air. So the trampoline gives a maximum upward acceleration of 14.2. Calculate the maximum upward force on the gymnast. So at this point, when it is in contact, the weight is acting downward. The normal contact force R is acting upward, and that is causing an acceleration upward. So upward acceleration is due to the upward force from the trampoline, or we can also say that as R. So we can say R minus W is equals to F, because the resultant force, if we need the upward force, so upward force R is equals to F plus W. And F is equals to MA, like in place of, you can also write like R minus W is equals to MA. So R is equals to MA plus W. M is the mass, which is 58. A is the acceleration, 9.81. A is the acceleration, which is this acceleration, the maximum acceleration 14.2, plus the weight is mass 5.8 multiplied by gravity 9.81. So this will give us the value for R, or the upward force. That will be 1390 Newton. This question is related to the waves. A student connected a signal generator to a loudspeaker. A student arranged the metal plate in front of a loudspeaker as shown. The student left the gap between the metal plates. The sound wave from a loudspeaker passes through the gap, and they're approximately same size as a wavelength. The student stood at point X and then hear a loud sound. Then he walked straight in the direction. As her position changed, the sound became quieter until she heard no sound. Explain why the sound became quieter until no sound, and explain with reference to interference. So actually what happened, when the speaker is producing a sound, the wavelength of this sound which is produced is equals to gap size. So this causes a maximum diffraction. And the two diffracted waves from the slits or the opening or the gap interfere at different position. For point X, the two waves cover the same distance. So the path difference is zero. Like how much distance covered by sound from the first gap and the second gap is same. So what will be the path difference? The path difference will be 0 lambda. When the path difference is 0 lambda, we'll have a maxima or constructive interference. That's why it will, if it's a sound wave, it will be a loud sound. But as he move at this position, what happened? The sound, like no sound is there. So what is the reason for that? Now the path difference, the two waves which are traveling, the path difference of these two waves equals to half of wavelength. And when it is path difference is like half of wavelength or fraction of the wavelength, we'll have a minima. Minima means like destructive interference. And when there is destructive interference, there will be no sound here. If it's a sound wave, then no sound. If it is a light wave, then you will have a dark region. So how you score 6 marks, because this is like the structure answer. So first thing you will mention, the loudspeaker produced a longitudinal wave because the type of wave, and diffraction and interference can happen for both longitudinal and transverse waves. So first what will happen, the waves which are passing through the gap, the wavelength is equals to gap size, which cause a diffraction like spreading. At point X, what will happen? The two waves travel the same distance, so they will have a path difference of 0, or you can also say they are in phase. As a result, there will be a constructive interference, so we hear a loud sound. But as observer move from point X, the path difference changes. and it will become half of the wavelength, or the two waves become anti-phase. So they cancel out the effect of each other, and we have a destructive interference which cause no sound. Is it clear, this one? So 6 marks you will score in this manner only. You have to use these terminologies, and it's a very common type of a question in exam in which you explain diffraction and interference. This question is related to momentum. Astronauts return to Earth in a descent module. Before entering the Earth atmosphere, the modules separate. The orbital module and the service module is there. The orbital module and service module move away from a descent module in opposite direction as shown. Determine the velocity of the descent module after separation. You should consider the momentum along the horizontal line. Center is there. The mass is given. So whenever like any separation is there, if total momentum before is 0, the total momentum after should also be 0. Like you have to use the conservation of the momentum. The momentum before must be equals to momentum after. The sum of momentum is equals to the sum of momentum after. So before the separation, like they were all together, before entering the module separated. So before the initial momentum is 0. So, and the final should also be 0. So example for the orbital module, the mass of orbital module is 1350. So 1350 multiplied by speed 0.82. Plus the mass of the descent module, that is 2950, and the speed example is v. Then the mass of the service module, that is 2100, but it move in opposite direction, so speed will substitute as minus 0.58. And we simplify, we'll find the value for v. Like what we consider the descent model is moving in the same direction as the orbital module. Like this is our assumption. If we get the answer, our final answer is positive, it means this is correct, like our direction was correct. But what if our final answer come out negative? It means the direction which we choose, it's not moving in the same direction, it actually move in opposite direction. So you just have to use a conservation of momentum and work out like the momentum before equals to momentum after. So just simplify this equation and find the value for v. But if the value for v is positive, it means the direction which you choose, that is correct. If you get a negative answer, it means the direction which you choose is actually the original direction is opposite. What if the same question was there and they say all were moving together with a certain speed, like the orbital module, the descent module, and the service module, and they mentioned they all were moving initially? Yes, you can. If you consider that, for example, what if you consider it is moving in the direction of the service module? Okay. So in that case, what you will take, because the direction, you have to select which direction you are considering positive. Example, if you're considering all the velocities on the left hand side are positive, so all the velocities on the right hand side must be negative. And when you solve this, so this will be 0. The mass, it will be 1350 times 0.82 plus the mass will be 2950 times minus v plus the mass is 2100 minus 0.58. And you will solve this question. If your answer, the final answer is positive, it means it has moved in the direction which you choose. But if your final answer is coming out negative, it means the direction which you choose, it's opposite. So it does not make difference. You can consider both are even, you can consider that example, it move in this direction. So left hand side direction, right hand side direction, you consider positive, left negative. So it's the same idea. It depends on what you get as a final answer. If the final answer you got a different negative value, which means the direction which you choose is actually actual direction is opposite. That's why how to recognize the direction of a V. That's I'm saying, if you get a positive answer, it means what you choose is the right one. But if you get a negative answer, it means what you choose, actually it will move in opposite direction. In question 10, the photoelectrons are released from the plate with a maximum speed of 3.51 exponent 5 meter per second. Different metals are there with the work function. And ultraviolet light UV is there. Deduce which of the metal is most likely to have this. Okay. So the ultraviolet light which is used in the experiment, like there's a metal. When the light falls in the form of photon, electron will absorb and it will move out. It will have a kinetic energy. So energy of the photon, incident photon, is equals to work function plus the kinetic energy. If energy minus the kinetic energy, what we get a work function. Now, how to work out the energy of a photon? Energy of incident photon, we have the formula E is equals to HF, or we can use E is equals to Hc over lambda. So H is a Planck's constant, 6.63 into 10 power minus 34. C is the speed of a light, 3 into 10 power 8. Don't forget the unit conversion, 310 nanometer. So 310 into 10 power minus 9. This will give us the energy in joules, the energy of the incident photon. Which is 6.42 into 10 power minus 19 joules. What about the kinetic energy? Because when we take a difference of energy of the photon minus the kinetic energy, we get the work function. So kinetic energy is half mv square. So it will be half. M is the mass of electron, which is, these are the constant value it will be given. So it will be 9.11 into 10 power minus 31. And the V is the speed at which this electron is moving. So 3.51 into 10 power 5 square. That will give us the kinetic energy. So kinetic energy of the photoelectron, that is 5.6 into 10 to the power minus 20 joules. And we take a difference of these two energies to work out the work function, to get the work function. So 6.42 into 10 to the power minus 19 minus 5.6 into 10 to the power minus 20. We got the work function, which is 5.86 into 10 to the power minus 90 joules. So this will be the energy of this, like the work function minimum possible energy. Then we check the table, 5.86. So it's like 5.89. It match with this work function matches with magnesium. So it means this metal is magnesium. So this was a pop quiz 1, which was related to unit 1 and 2 topics.